All of these different mutations can result in different types of effects. So, for example, they might cause morphological effects. These are things that would change appearances. They might cause conditional effects. These are effects that only occur under certain conditions. So, for example, you may only have the phenotype when you're cold or when you're hot or at certain times of year. And you might not be able to see the effect of the mutation the rest of the time. Some mutations result in lethality. So they might cause a difference that will result in the organism dying young. Or they might change the way the organism needs nutrients in order to survive. And these are often called auxotrophic mutations. Part of what causes these differences and how phenotypes might be impacted by a mutation is how it influences the protein in general. There are three main categories. The first is the null. Null alleles result in the complete loss of the protein. This means that no protein is made at all. This could happen because there's a very early stop codon or by a mutation that prevents most of the transcript from happening or prevents the transcript from being made at all. They could also be mutations that prevent the protein from being translated, but they all result in no protein existing. Loss of function alleles result in proteins that either cannot do their function or their function is impacted negatively in some way. This might be because part of the protein's shape has changed or because part of the protein that should interact with something is missing. Gain of function alleles are the rarest alleles, and they result in acquisition of a new function or an increase in the protein's ability to do its previous job. So these are much less common. The most common types of mutations are nulls and loss of function alleles, and gain of functions are more rare. Now, what do you think about whether or not these would be positive or negative effects? Does the loss of a protein or the gain of a function necessarily mean that the mutation is good or bad? It doesn't. So gaining function can be equally bad. It depends on what that function is and where it's happening. Losing a function might be okay. The type of mutation doesn't necessarily mean that everything is going to be bad. So here's an example of a loss of function mutation. This results in things like albinism. So for example, in order for a mouse to have color, it needs to have tyrosinase activity. When tyrosinase is present, the mouse is able to process its color and put that color into its fur. However, when tyrosinase is not produced, the mouse is unable to produce its color or migrate that color into the mouse's fur. Partial mutations, such as this one here, where only one of the alleles results in function, can often look the same as the one where both are working. But if loss of function or null occurs at both of the alleles, you will always see that effect. Gain of function mutations work a little differently. So for example, in this mutation, we are changing the way the protein is made when the mutation occurs. An example of that would be something like this ultrabithorax mutation. Here, we're changing the identity of part of the body to mimic the previous part. This results in gaining a different function at this location. While it might seem like this fly should fly better with 4 wings, it actually doesn't. Because its body is so short, the wings get in each other's way, and the fly has a really hard time flying. Most